When finding a polynomial function given its zeros, you are essentially working out the equation backwards, meaning you are taking the answers and undoing what you have normally done. So for the first example, we're going to find the polynomial function f with real coefficients having the given degree in zeros. We're going to assume that a is 1. It's a degree 3, which means its highest exponent is going to be a cube, and the zeros are 0, 4, and -3. So first thing you want to start off with is the zeros. So we know that x equals 0, x equals 4, and x equals -3. Now this is where you normally stop, but this time we're going to go backwards. So instead of solving for x, we're going to move everything back over. So x equals 0 is still going to be x equals 0. We're going to subtract 4 over, we're going to get x minus 4 equals 0. And we're going to add 3 over, x plus 3 equals 0. And now this is where we would separate and solve for the answers, but this time we're going to bring them all back together. So we're going to get x times x minus 4 x plus 3 equals 0. And again, we're going to bring it all back together, so we're going to multiply the two parentheses together. So we're going to get x squared minus x minus 12 equals 0. Then we're going to distribute the x across. X cubed minus x squared minus 12x equals 0. And then finally, because we want a function f, we're going to turn this into function notation. So we're going to have f of x equals x cubed minus x squared minus 12x. And again, degree 3, which means the highest exponent could be a cubed. And here it is, the highest exponent here is a cube. And then a is equal to 1, so we're not worried about anything else. This will be the function containing these zeros. So that wasn't too bad, but what about stuff with complex zeros? So a degree 4 with zeros 3 plus 2i, and 4 with a multiplicity of 2. All complex zeros have a pair. So x equals 3 plus 2i is going to have the conjugate pair, x equals 3 minus 2i. And then 4 with a multiplicity of 2 just means that 4 exists twice. So we're going to have x equals 4 twice. And now we work it all backwards. So x minus 3 minus 2i equals 0. X minus 3 plus 2i equals 0. X minus 4 equals 0. And x minus 4 equals 0. Combine them all together and get x minus 3 minus 2i. X minus 3 plus 2i, x minus 4, x minus 4 equals 0. Now here's the hard part, or the long part. We're going to distribute everything out, and that's going to take a minute. But it's just tedious amounts of algebra. Just take your time when doing this. So when distributing out the x minus 3 and minus 2i to the x minus 3 plus 2i, you are going to get x squared minus 3x plus 2xi minus 3x plus 9 minus 6i minus 2xi plus 6i minus 4i squared. And then for the x minus 4, you're going to get x squared minus 8x plus 16 equals 0. Now, it's a lot here, but the nice thing is anything with an I, except for I squared, should cancel out. So positive 2xi, negative 2xi, gone. Negative 6i, positive 6i, gone. And then here we can just combine like terms. So we're going to get x squared minus 6x plus 9 minus 4 times negative 1 because I squared is -1. Then x squared minus 8x plus 16 equals 0. And then we're going to combine everything over here. So x squared minus 6x plus 13, then x squared minus 8x plus 16 equals 0. Again, distribute this all out one more time, and we're going to get x to the 4th minus 8x cubed plus 16x squared minus 6x cubed plus 48x squared minus 96x plus 13x squared minus 104x plus 208 equals 0. So I know that took a minute and I went through it fast, so just double check your work or pause it just to make sure you got everything there. Finally, combining like terms, x to the 4th minus 14x cubed plus 77x squared minus 200x plus 208 equals 0. And then we're going to turn this into function notation. So f of x equals x to the 4th minus 14x cubed plus 77x squared minus 200x plus 208. And this is the function for the 4 given zeros. Again, a degree 4, so this is a 4th degree.